Before we get started, let me just say a few words about some upcoming events. Mid-March is the launch of Artemis 2, and I think Mark spoke about that at the last meeting, which is the first astronaut mission around the moon since Apollo 17. So for those of us of that era, of the Apollo era, this will be the next time we'll see folks in lunar orbit. March 21st, I mentioned this last time, the Annapolis Symphony Orchestra is doing a piece called Space, an out-of-this-world symphony performance. The tickets are relatively inexpensive, I think like $10. So if you get a chance to go online and take a look at the performances if you're interested. As far as some upcoming meetings, the next meeting, March 18th, again, the third Wednesday of the month, Catherine Sterling's, who is on the board of Dark Sky Maryland, is going to be doing a presentation on saving dark skies, which is all about light pollution, the effects of light pollution, and everything that that affects. Also, Liz Schilder, is Liz here tonight? She was going to try to make it. She is a ranger at Quiet Waters Park, in fact, who has an interest in astronomy. And she's going to be talking about quiet waters at night. On April 15th, which is in the middle of International Dark Sky Week, we've gotten special permission from the superintendent of Quiet Waters Park for a night out at Quiet Waters Park. So some of the folks who are here who are presenting their telescopes, I'll be asking if it's convenient for them to come out that night so you can actually view through their instruments what they'll be talking about this evening. There'll be a rain date also. Now, we do have to make it available to the public because it is at Quiet Waters, but you all will get an advance email, so first come, first serve. So when you get that email, if you're interested, I'd say sign up right away. It's going to be limited to 40 people. I'm sorry? April 15th, tax day. You can remember it that way. So those are just some upcoming events. Any questions about that? Okay, I was reminded that I have the wrong date on this, so, thank you, Joan, reminding me of that. So tonight, we'll talk about various instruments for viewing the night sky, from sextants to telescopes. As I said, unfortunately, Frank Volpe can't be here this evening. I will do my best to just give a quick overview, but I'm going to reserve it for him to do any details. We'll be talking about binoculars. We'll be talking about two smart telescopes. A smart telescope, and by the way, these instruments are at the two tables here, so I encourage you, when we're done here with the presentations, we'll try to have enough time after for you to go up and actually talk to the folks who own the various instruments. Smart telescopes are the latest thing on the market, and as the name implies, very user-friendly. So a layperson who doesn't know anything about astronomy can set it up, say, I want to go take a look at the Crab Nebula, punch it in from your app on your phone, you'll salute to it, take some images, save it to your smartphone, so very, very user-friendly. Rhonda is going to be talking about can I call it an antique tabletop? Okay. And she'll say more about that. And then Matt's going to be talking about the telescope he has here. Again, I encourage you, when we're all done, to go up and talk to the folks. We'll have some time to do that. So in Frank's absence, I'm going to do my best just to give a quick overview of the sextant, since it is what I'll call a instrument that looks at the night sky for navigation purposes. But just as you probably have ever seen a sextant, it's an instrument that looks like this. It looks very complicated, but as Frank says, all it does is measure angles. That's it. So if you imagine taking your thumb and your finger and let's say you point up to the moon with this finger horizontal That's basically a sextant. If you just measure this angle here, right? Or if you're trying to measure the height of a tree, right? And you go like that and you get that angle and you know the distance to the tree, you can figure out how high it is just based on high school geometry. So that's all a sextant does, is it measures an angle. Now, there's a lot more to it, obviously, with trying to get it horizontal, trying to make sure you've got it kind of centered okay, so there's an eyepiece. So all that extra stuff on a sextant is just to help you with that. But that's all it does, measures an angle. So, and again, it uses mirrors. It's got a little small telescope. It measures the angles of the sun, moon, and the stars to determine their location. And as I sort of implied, you could also use it to measure terrestrial things, trees, mountains, buildings, again, if you know the distance to them. And Lewis and Clark use the sextant to navigate, to explore and navigate Western United States. I had coffee with Frank the other day as he was talking about this, and he indicated that there's an interesting book, and if he were here, he would tell you the name of it, which describes the journey of Lewis and Clark using the sextant to map out basically going across the United States. I didn't know this, but Frank pointed out to me that their original mission was to try to see if there was a way of connecting the Columbia River with like the Great Lakes or something. So kind of an interesting historical point on that. So they use a sextant basically to map out going across. Yes? The question, would using a sextant allow you to measure distances? If you knew the height of something and you knew the angle, then you get the distance. Again, just geometry, but not with stars and moon. So if it's terrestrial, I suppose you could, because again, angle, one side of a triangle, you can get the other side of a triangle. Okay, so how does it work? It takes a sun sight at the moon to measure the angle between the horizon and the sun, namely, just as I sort of indicated. It also measures angles, as I said, with respect to stars. It helps to compute latitude and longitude. So the measurements on the sextant, there is a table at a website called thenauticalalmanac.com that will then tell you, after you've put in the date, the angles and all of that, will give you the latitude and longitude. And what it's used for, navigation on ships, airplanes, on land, and even in space. So International Space Station, folks there have used the sextant for, I'm not sure how they got the horizon, but anyway, I'll let Frank describe that. Frank is also would show an interesting demonstration that if you can't see the horizon, how you can determine the horizon with a bucket of water. So I'll leave that for Frank to describe. So that's it. We're each going to take about 5 to 10 minutes and move on to the next. So let me move on to Bob, who's going to talk about binoculars. By the way, these presentations are an increase in expense, by the way, and complexity. So, yeah, so I'll let you, if you want to just hold it, whatever.
Thanks. Good evening, everyone. I'm Robert Koski. I am an amateur stargazer, much more amateur than a lot of these. But I want to tell you tonight about binoculars and how they can be a really great low barrier to entry way to view the night sky. Sure. Can y'all hear me? Okay, cool. So what can you expect to see from binoculars? Well, it's more than you would think. It's definitely more than the naked eye. You can identify different star types. So not last time, but I think the time before, we heard about the different types of stars and the different colors that you can see. You can see that with the binoculars. You can see planets, you can see moons, including our own, obviously, and really just greater detail than you could normally. There are a lot of pros and cons with binoculars, but I'll focus on the pros since I'm pro binocular. First is they're very inexpensive. Compared to other optics you can spend a lot of money on. Uh, Binoculars are pretty low barrier to entry. There's no setup involved. You literally just take them and you can look at anything within a second. And they're easily accessible. They're very portable. They also have other uses, and that's actually how I originally bought these. I was interested in looking at some of the birds in my backyard, and I wanted a good, solid, sturdy pair of binoculars. And when this club came around, I thought, hey, I've already got them. Might as well use them for this too. There are a couple of cons. If you have a natural tremor to your hand, you may need to get a tripod to help steady yourself because they're prone to movement. You know, if you don't have something to brace yourself against, sometimes you can get a little bit of wiggle, and especially if you're looking at things in the night sky, you want a pretty steady mount. They're obviously not as detailed as a telescope. You can look at things in pretty great detail with a lot of these devices, but with binoculars, you're basically going to get a magnification of what's there. And then there's a smaller aperture, so the opening is not as large, so it doesn't let as much light in. So you may not be able to see things like some of these over here that actually track the night sky. One of the reasons why that tracking is so great, and I'm sure they'll get into it, is because it lets more light in, and you can see more stuff. So when you're looking at binoculars, you might be asking, what do all the numbers mean? And you know, if you've ever picked up a pair of binoculars, there's usually three numbers on them. If you go on a spec sheet for binoculars, you can really, I mean, geez, the spec sheet on them is like a whole page long of like a bunch of numbers. We're going to focus on three because that's really all that matters to an amateur astronomer here. The first is the magnification. So on this pair of binoculars, it's 8 times magnification. For stargazing, it's best to aim for the 8 to 10 range. If you go any higher, you're much more likely to have a shake. If you're very, very zoomed in, it's much more prone to make the sight very, very wobbly. So 8 to 10 is a really good range where you get good detail, but you can still have a steady image. Second is the aperture. So, like I said, bigger means that there's more light, and the best to aim for, I'm so sorry. Did I turn that off? There we go. You want to aim for the 40 to 50 millimeter range, and this is basically a trade-off in weight. If you go any larger than this, the housing starts to get pretty big, and if you're constantly going up and down, you can just have some natural strain and fatigue. So it's really just a trade-off in weight and bulk. And then you don't want to go any lower than about 40 millimeters. Some of these that you'll see have a little bit smaller aperture than that, but for a handheld device like this, lower than 40, you're probably not going to see as much as you might want to. So this is kind of the range you want to stick in. And then finally is the field of view. So this 7.2 is the degrees in the field of view. And basically, this is important if you're viewing things on Earth and in nature, because it shows you how much of, if you had a pizza of the sky, this is the slice of pizza that it can see. So at 7.2 degrees, that means that at 1,000 meters, you would basically see like 60 feet is what that works out to. For stargazing, it's not that important. You know, we're looking at things that are way up in the night sky. Your field of view is not going to be as important as the other two numbers. So my binoculars are a Nikon ProStaff P3. They're 8 by 42, so that means that they're 8 times magnification and have a 42 millimeter aperture. I selected them for multiple reasons. Really, I should switch it around. First, I wanted to bird watch, and then I wanted to stargaze. They were really budget friendly, and they're very durable and comfortable. I think they were waterproof up to like 3 feet. So if you dropped them in a pond or whatever, they probably wouldn't get damaged. I wouldn't try it. They're also comfortable. You can wear them for a long time. They're not going to strain your neck, just, you know, having them hang there. They've worked really well for me. I've had these for, I think, a year and a half, 2 years, and I've been very happy with them. These are some of the favorite things I've seen. First, obviously, is the moon. It's just really cool to go out in your backyard and be able to immediately look up at something and see it in greater detail than if you were just here on Earth. I've seen many moving satellites. One of the really cool things, especially with this pair of binoculars, is that some of the satellites that you see going across the night sky, you can actually kind of track them with a pair of binoculars, which you can't do with other devices with ease. I mean, maybe if you're really handy with your telescope, you possibly could, but that's one benefit to a pair of binoculars, that you can actually see those in pretty. It's pretty cool to see them move. This is one of my favorite constellations, is Orion. It's very well known, and you can obviously see it in great detail. But one of my favorite things is if you look a little bit beyond Orion, there's a line that goes from his belt through Aldebaran, and you can see the Seven Sisters constellation, or Pleiades. I hope I'm pronouncing that right. Um, I thought this was really cool because, at least from my backyard, you can just barely see it in indirect vision. It's almost like a cloud of stars. And it was really cool because I could see it with my binoculars and look up and actually see all seven stars. So it was really neat to see that. I just thought it was really fascinating. So in summary, binoculars are a really great tool for stargazers of any skill level. But really, especially for newcomers, you can see a lot with binoculars. And even if you're more advanced, having a pair of binoculars is really handy because you can see things and kind of use it for targeting, the objects that you want to look at. Magnification and aperture are really important. 8 to 10 and 40 to 55 is kind of the ballpark where you might want to look at. And the prices are really flexible. I mean, I've seen prices as low as $50 up to, $200 is what you can expect. I think this pair was around 160. I got them on sale for like, I think 135 or something. I mean, it's a pretty decent deal. If you want to go super big, I mean, you can get really expensive in the $500 to $1,000 range if you really wanted a nice, really nice pair of binoculars. 50 to 200 will do it for you. That's all I've got. I put a couple of references in here, so if you want to go back and look at them, these are some really good ones to look at. But otherwise, thank you very much. I really appreciate your time. Oh yeah, I'm sorry. Any questions? You're welcome to come and look at them. I'm okay. You can handle them. Do whatever. Yes. I mean, probably not. The only thing that I think has probably changed is the housing has gotten better. So, they're more durable. I think if you look at older pairs of binoculars, a lot of the time they're going to be a little bit more fragile than these. These you could probably, I'm not going to do it, but you can kind of toss them around a little bit and they're not going to totally break. Yes, Jim.
I think that the lens coatings, things like
Yeah.
that have improved a lot. For stable.
Yeah.
But
You can buy stabilized binoculars too, that's much more expensive.
Yeah.
but the optics have improved that.
Yeah.
And weight.
Yeah, weight would be a big one. Weights. Yeah. Yep. Yeah. Thank you. Yeah.
All right. Thank you, Robert. Jim. Okay, next up is Steve Simon, and Steve will be talking about one of our first of two smart telescopes.
Is this good? Okay. All right. So here we go. This is my Sea Star, the newest family member to the household. These are two sample images that I've taken. I'm not very good at this. I'll say that right away. It's all brand new to me. So we had the moon, and I was playing around with a little bit of the filtering of light, and then the Crab Nebula, which was pretty fun to look at because you look up at the night sky and you see like a planet or some stars, and you don't see the thousands of other points of light. And so this little gadget that I have now, you zoom in and it's all of a sudden, it's like, it's a whole new, like a galaxy out there. So it's pretty cool. Starting off research and purchasing, I had no clue what I was looking for. I just know that I wanted a digital telescope. And some of them are better for planets, some of them are better for the moon, some are for nebula. So I started reading through all this stuff and I was like, what do I really want? And I wanted everything. So I got something in the middle. And The one thing was I didn't want to go spend thousands of dollars, but I also didn't want to get like the low end one where I'd be upset and then have to spend another couple $100. And so I went halfway and it's kind of in the middle. And especially looking for the app. Some of the apps have so many things that you can do that you get lost in it. And I don't know if you'd enjoy the time in actually using the telescope. So the setup, I'm very impatient, so I rushed into things, and so I had to dial it back and redo things a couple times. So if you do purchase this type of telescope, I say take your time, read the tutorials, look at the videos. They're very helpful. Something that's interesting about the telescope is that it has its own network. So while you connect to the internet to like get firmware updates or other things or view the tutorials themselves, you have to connect to the actual telescope, which doesn't have internet connection. So you're kind of like in between two worlds, and you kind of got to get used to that. As I mentioned, the firmware update. So it downloads, and then when you connect to the telescope, it starts installing the update. So a couple times, and there are frequent updates too. So it's a nice thing. Actually, there was one glitch that happened, and then like a week later, the new update came out, new firmware update came out, and it actually fixed it. The location. This was one of my impatient setup things. Is I somehow fumbled into manually setting up the location, and I had to like figure out how to get back out and then have my tablet do the GPS location to actually get the real location. So that's a thing to note. And there's so many fun advanced settings like filters and lights and just colors and brightness, and still going through all that, but it's really fun stuff to learn. And as far as using it, when it says about the object is visible in the app, it actually says, here are the things that are visible in your based upon your location. That the location doesn't take into account that your roof's in the way or there are branches in the way. So even though it says it's visible, it may not actually be visible. The stacking is fantastic. I mean, what a great feature. And I never knew anything about that. I mean, I kind of understood what it was, but again, being impatient, watching the stacking happen, it's like every 10 seconds it layers and then it hones in more. So like I'm sitting on the couch, which is a nice thing, by the way, about this, is that you put the telescope outside and then you go inside. So when it's freezing, it's fantastic. But it's really interesting to watch after like 10 minutes, like 5 minutes to 10 minutes, to seeing how an image really starts focusing in and you start seeing more detail. It's really fascinating. Again, another impatient thing, make sure the tripod, all the legs are stable. Stacking error, that was user error right there. And again, the tutorials are fantastic. The videos, people are very helpful out there. Highly suggested when getting into this, if you do get into it. So I think that's questions.
So did you take these backyard or front yard?
If backyard, yeah, and just put them on the table, put the telescope out on the table, and just the moon was a quick shot, that was just one. But the Crab Nebula, I took 1 minute, 5 minutes, and then I think 8 minutes. And it really, it was fantastic. I should have let it go like for 20 minutes or something like that. Yes. Yes. Yep. The one standing up on the right. The tall one. Yeah. The telescope on the table, the second in the middle. Yep. Yes. Yep. And then the camera, the app is how you view it. So the app actually is your lens. It's how you again, you put the telescope outside and you just let it do its thing. Yep. Yeah.
When it comes to optimizing the image, like
So it's, yeah, sorry about that. So about optimizing the image, does the telescope do it, or or does it manually happen? Is that, yeah, yeah, the advanced settings, there are ways that you can actually do it yourself. There are like overrides, but mainly so far it's just been what the app does. Yeah. Yeah,
If you say that it's better that the telescope set up location automatically, not try to put something in manually.
yeah. Yeah, so the question is about let the telescope do the location, the GPS, let the app do it. Yeah, so it's when I did it manually, because it allows you to select manually. You can go through the longitude and latitude, but it's much better to let the put the phone or the tablet, let it let the GPS do it. Yes. So what's the model and the name of the brand? It's C Star and it's S50, and the price was $575. Yes. No, I have not yet. I've only had the telescope. The question was about long exposures. I've only had the telescope for 3 months, so just still playing around.
Okay, great. All right. Thank you very much, Steve. Thank you. So speaking of dwarf 2s and 3s, our next presentation is by Carl, who's going to talk about the dwarf 3. So good segue. You go, Carl. You keep it up here and you keep it up.
Yep. Yeah, I feel like saying thank you. I've been in astronomy now for a couple of decades, not professional, amateurs like I presume everybody here. In the process, I've gone through quite a few different telescopes, and in the process, I've also gotten older. And one of the things that I found out about telescopes is that if you get one that's rigid enough, that's big enough, that it suddenly becomes hard to move around, and it becomes hard for an old man to bend over to take a look at something that's very high in the sky. So I've been on the lookout for some time to find a small unit that I can move around easily. And that brought me to dwarf 2s and 3s. I own a 3 right now. Yeah. So to give you an idea of the size, and the weight is about 3 pounds. It's about the same as my large coffee can at home. So, and next to it, I think you can see, no, that's the next, must be the next image. Okay. Here's a couple of images that were taken. The sun is an image of taken by a dwarf 3. This one here, quite spectacular. You can see sunspots very easily, and there's a number of them that day, quite a few more than I thought would be there. And next to it is a dwarf 2 image of Andromeda. I taken over the course of about an hour, a couple of hundred images. Now, when you look at something like a galaxy and you're thinking about a telescope, a regular telescope, you won't see a galaxy. The amount of light is too small for the human eye to be able to form an image. So you can look all you want. You can look off center at the more sensitive parts of your eye, and you might see a smudge, but you won't see any kind of detail at all. In order to get the detail, you have to accumulate that very faint light, and it's done with this technique that's come up here. It's called stacking. If you're familiar with higher mathematics, it's just like taking an integral. What you're doing is you're taking the energy in, and it's adding and adding and adding and adding and adding. Now, the next thing that you need in a stacking system is you need high stability somehow. You can get it with a computer, taking images of the sky and taking out the differences between images. You can potentially do it with a particular kind of mount called an equatorial mount that I'm sure one of our presenters will talk about. But with a simple mount like this, what the telescope has to do is it has to take out the rotation of the star field. As you're looking at a star, the stars around that particular star that's in the center of the image are actually moving because the Earth's moving, and we're not the axis is not aligned with the axis of the telescope. So what this telescope and the telescope that you saw before does is there's a little computer in the inside, takes the images, derotates the stars around it so that the star field is stable, and then stacks these images. And you stack enough of them, it brings out detail like this Andromeda galaxy. And there's actually two galaxies there. I don't know if you can see the other one just down and to the right, down below. So all of a sudden, out of nothing comes a lot of interesting things that you would not see with a regular telescope. Okay, I think I've talked about most of this here. And you already heard that the really nice thing is you can be looking on your easy chair in the living room in the heat or the cold. Okay, so what's this really good for? Well, it's really good for deep sky stuff, for nebula, for galaxies, for that sort of thing. It's good for the sun and the moon because the images are large and they're close. It's not good for planets. And the reasoning is there's a thing called point spread function that's part of an optical system that has to do with the size of the aperture, the size of the lens, the major opening. In order to see fine details in an object, especially a small object, like the planets would be in the field of view, you have to have a fairly large aperture. The bigger the aperture, the better. But this aperture in a dwarf is only 35 millimeters. It's not at all large enough to see details like the big red spot on Jupiter, for example, or the polar caps on Mars, etc. So for that, you would need a scope that has a larger aperture like this one over here, for example. Now, the dwarfs, both 2 and 3, are unusual in that they actually have two telescopes. One is a wide field of view. One has a very narrow field of view for looking in deep sky. The wide field of view is very good for doing things like following wildlife. And the control system in it is really quite advanced and can follow objects. I have not done this, but I have seen examples of the wide field of view actually following a bird in flight. So all of a sudden, you've got a telescope that you can use for a couple of things, both during the day and night. This one has built-in filters. So there are filters for light pollution that are built in. And it also comes with a clip-on filter for viewing the sun, which is what you would need to keep from destroying the cameras looking at the sun. Okay, so the difference between this and the two, it has separate batteries that you can change out. This one has a single internal battery of very large capacity, many, many hours of on time. And another thing is, if you get one of these things, you're going to need to have an iPhone or an Android device or something that will talk to it through Bluetooth and take the app that's been developed for it. Okay, that's my 10 cents here. Questions? Yes. Cost about $5.50 roughly. You can find them plus or minus about $50. Now, Dwarf Labs, which makes it, wants to sell you a tripod. They call a hydraulic tripod. I'm not sure what the hydraulic part is, except that it's more expensive than a normal tripod would be. I bought a tripod for this thing, but I'll tell you, I don't use it. I would only use it if the ground was wet. I sit this right on the ground. You have an incredibly stable package. There's nothing wiggling out here at all. It's relatively unaffected by wind and so on. And because you don't have somebody sitting at the eyepiece looking through it, hitting the eyepiece, knocking it out of the field of view, you have a very stable picture. Yeah. Any other questions? Yes. Yep. So yeah. So the unusual thing is the optics is like a periscope. So we have one side here that takes a narrow field of view. There's a mirror in there, right angle mirror, and it shoots it down to a sensor down at the end. The opposite side does the same thing, shoots down to another sensor down at the other end. I'm going to put this down here. Hopefully it will pick up enough. Yeah. The altitude and azimuth part of this control system is that this thing simply sets on this base down here, which has a tripod screw point to it, and just turns. This is azimuth. This is elevation here. And this is completely under app control. As a matter of fact, if you, yes, there. Yeah. So here's the narrow field of view. This is a knot hole somewhere up in the roof here. And I can point to different knot holes by just using this little joystick part of the app. I can flip. Come on. I think I have my fingers on it. No, it's not going to do it. It should. There we go. What? I think what's happening is I got my fingers in the way.
We saw it.
Anyway, you get the idea. You can flip it from one side to the other. And there's a little box in here, and this box will track. You can tell it to track whatever's in the box. I think we're going to have to move on. Yep.
All right, thank you very much. So those were two examples of, again, smart telescopes. And as you saw, very easy to use with apps and so on. The next two presentations will be about telescopes, and we'll start with Rhonda to talk about, do you want to call it an antique telescope? Vintage. Okay, vintage telescope. So Rhonda, you want to take it away? You want to come around here? You just hold it up.
Yeah. Hi, everybody. So I inherited this telescope from my dad, who was an amateur astronomer and a scientist who specialized in optics. So he really knew how to use it. And he passed about 20 years ago. And for most of that time, I was afraid to take it out of the case. It had this big sign on it that said, telescope, very fragile. So I just kind of took that as a sign that maybe I shouldn't, mess with it. Anyway, I did inherit from my dad a curiosity about the sky, and I finally got up enough courage to open up the box. And I'm glad that I met Dennis at last year's Open Sky event, and he helped me understand how to use it and put it together. So I appreciate that. So I didn't inherit my dad's scientific knowledge. I'm a psychotherapist by training, so don't ask me too many questions because I can tell you how I feel about it, but I'm not sure I can tell you much else. So, so this is kind of they call it a grab and go telescope. So it's a classic tabletop telescope, and it's pretty light. It's about 5.5 pounds, and you can travel with it. So my dad actually did that, and he and my mom went to Aruba in 1998 to see a total solar eclipse and brought the scope with them. So it's pretty easy to move around. The little one. Yeah, the little one over there. Yeah. Yeah. It's a Mead, which I guess they're no longer in business. So I can't add to it, or if there are some repairs I'd like to do it, there's really nobody to call about that. But it is a pretty high quality telescope and a nice alternative to some larger models. It has 3 legs. I have not put them on, but that will make it tilt to the sky so that you can track. And it does have a motor, so you can automatically track astronomical, whatever you're looking at in the sky. I've got 3 filters for it, a solar filter for looking at the sun, although Dennis tells me it's so old, I'm not sure I should use it because if it has any cracks, it can be quite dangerous. So I haven't tried to use that. It's got a light pollution filter and a polarizing filter. And I recently bought a smartphone adapter so that I can clamp my iPhone onto it and take pictures that way. But I haven't really tried that much, just once so far. And at Dennis's recommendation, I added a laser pointer so that you can point to what you're trying to aim for to help you find the image that you're looking for in the sky. Let's see. What else do I want to tell you? Oh, yes. Sorry, I wasn't paying any attention. Yep, that's my dad and his telescope. And that was about 20 years ago. He was I'm a very novice astronomer. He was quite experienced. He built his own telescopes, and we grew up with telescopes in the 1960s, looking at the moon and seeing the craters of the moon from our backyard. So I was used to having telescopes around a lot. This is one of his smallest scopes. Okay, that's the scope itself. You'll be able to go and see it. And the various accessories, the laser pointer, the smartphone adapter, and the various filters. And on the other side, you can see the manual. I brought the manual because I can't really speak to the details of the optics, but anyone who's really interested, it's pretty straightforward manual and you can take a look at it. So, and I'm very happy to share it with the group when we go out to look at stars. Please feel free to have a look. And I guess we're doing that soon in April, which is, I'm really looking forward to. All right. That's it. Oh, I think, well, this was it was made in mid 80s, between 88 and 98, somewhere in there. And at the time it was about $500. I don't know what that equivalent is today. Yeah. Yeah. And you can find used ones online, I noticed on eBay because I was looking at prices. So, yeah.
Instead of that motor, what control Is it track? How does it track? Is there anything that controls it or?
Yeah, you have to actually literally plug it into the wall or into some, power, and then
No, you say, I want to see Saturn.
oh, you can't talk to it. It's not that smart. Yeah. I think what you do is you point to what you're trying to look at, find it, and then it will keep it there. Right? So yeah. Thank you for asking a question I could answer.
Any other questions? Great, thank you, Rhonda.
Yeah.
Okay, and last we have Matthew, who's going to be talking about the telescope that you see on my left here. So,
Thank you very much. So my name is Matthew Nichols, and the telescope I brought tonight is the Celestron that you see right there, which Dennis asked me to answer 3 questions during this short presentation. One is to identify the specific make and model of this telescope. Well, it is a Celestron. The aperture's 6 inches, about 150 millimeters. And here we go. Got it.
actually, I pulled that up. You just want to use these like this.
Brilliant. Okay. So the Newtonian it's not so much a model as it is a design. So the Newtonian, the light enters the tube, it bounces off of a primary mirror, and then it goes back to a triangle and then comes out the top there you see where the eyepiece mount is. Contrast that with the Cassegrain, which is the telescope we were just talking about. It's fully enclosed. The light passes through a corrective lens and then hits the primary mirror and then hits a secondary mirror and goes through the back of the telescope. You can see the eyepieces in the back there. Mine, I had so I bought my telescope in the early 80s. So it's over 40 years old. And that picture that you see there is the latest version of mine. And as you can see, not a lot has changed. My telescope, like that one right there, it's completely open. If you took the cap off the front of the tube, you could literally stick your arm down it and touch the primary mirror like my little cousin did when we were kids. Not a happy moment for me. But 6 inches is the aperture, and the focal length is 750 millimeters, and I'll discuss the importance of that in a second. So if it has like the Celestron Advanced VX6, I don't know if this had a VX or if it was called the Wildcat or Tomcat or something like that, but just know that it's a 6-inch Newtonian, and the Newtonian is the design. And at the time I bought that in the early 80s, the telescope and the mount, which it's a pretty nice mount for the telescope. I'll discuss that in a moment. The whole kit and caboodle was about $650. And that telescope, as seen there, which my fully manual equatorial mount versus this fully programmable, also equatorial mount, I believe that one is $1,450 new. And a lot of people buy telescopes like this, feel like it's too much for them to handle, or when really it's not. And I'll discuss that in a second too, if I have time. And they end up on the secondary market, so you can probably get a pretty sweet deal for somebody who decided they weren't using it enough. So that's the make and model. Why I chose this telescope, I probably gave some of that away already. I just want to emphasize a couple of points that were made earlier. Number one, when we were talking about binoculars especially, I couldn't agree more. Mount is very, very important. Doesn't matter how great your instrument is. If you can't hold it steady, you can't see anything with it hardly. And then also somebody mentioned the value of YouTube tutorials. I couldn't agree more. If there's a question you have I couldn't answer, or some observational technique you were interested in, all kinds of great things on YouTube. I chose this telescope because This is my contribution to tonight's presentation, and that is aperture. I wanted to max out the aperture. I believe when I was looking in the early 80s, my 6-inch Newtonian was about the same price as a 4-inch Cassegrain. I love the Cassegrain, the Schmid Cassegrain, because it's more enclosed, it's more maintenance free. That telescope right there is half the size of mine, but it has probably the same focal length, if not more. And mine is referred to as sort of a fast telescope, in that, you know, the light comes in the tube and then it's reduced relatively quickly. That focal length just refers to how far down the tube the light travels before it is brought to a point and focused and magnified in your lens. Which is why my 750 millimeter focal length, if I drop a 25 millimeter lens into it, this is how you could figure the magnification. 25 goes into 750 30 times. That's how much magnification I'm going to get. If I drop the same lens into a telescope that has twice the focal length, it's going to magnify twice as much. I have a little trick for that, though, which I'll talk about in 1 second. I shouldn't get into too much detail. Suffice it to say, the mount that I bought is a medium duty mount. It's overkill for the telescope that you see. However, at the time I thought, if I choose to add some weight to it, put a motor on it, for example, or if I want to mount a refractor alongside, like that, the dinky little sight, that only magnifies 6 times the viewfinder. But if I wanted to put something a little bit more robust on there, it could handle it. So a weaker mount, if it's going to strain under the weight of the telescope and the equipment, the camera, whatever you choose to add, then you're not going to get a lot of stability there. What have I personally observed with my telescope? I guess I should move on to, oh yeah, that's right. There we go. Use the buttons. So this is a great telescope, and another reason why I bought it, for planetary observation and deep space, deep space, because of its light gathering power. Dennis and I were talking at the opening, and when I first started looking at telescopes, I was really enthralled to what turned out to be the sizzle, which was the magnification. And I was told that, you know, a telescope like this with a 6-inch aperture, good rule of thumb, you multiply the aperture in inches by 50, and that's the maximum magnification is capable of. I would not even bother trying 300 times with that telescope, because when you magnify something, the best way I can describe it is you are limited to the amount of light that those 6 inches or 8 inches or 10 inches lets in. And then, you know, if I were to magnify the heck out of it, imagine like an image on a t-shirt, you know, where I'm just stretching that t-shirt. And yeah, I could stretch the distance between those lines on the t-shirt more and more and more and more, but I'm really also stretching out what little light I have coming into the tube. So the more you stretch it, you're going to lose the richness of the color. You're going to, somebody mentioned doing stacking images of the Horsehead Nebula. All of the viewing I've done has been visual. I have not used my telescope for photography, but it would be a good tool for that. And now that, you know, the technology has advanced such that I'm considering it. But if I were to, the sweet spot for my telescope is about 30 times to maybe 120, 150. I've never even gone up to 150, because the more I magnify it, you know, I lose that saturation of color, and all I can say is it's like stretching a telescope. I mean, it's stretching a t-shirt. Or, you know, would you rather look at a big stone or a big dull stone, or a brilliant gem? And I think just the excitement for me of astronomy is the gem. And another nice thing about this telescope is really, I used to think that I needed a whole bunch of lenses to make the most out of it. You don't. In fact, right now I only have two, but I know I've got two others sitting around somewhere. 25 millimeter, 20 millimeter, 15 millimeter. And I also, so that gives me 30, 40, and 50 times magnification. And then I had a Barlow lens, which they have Barlow lenses, which are like 2, 2.5, 3, 3.5, 4 times. So you can effectively extend the focal length of your telescope using those. So if with my little 2x, with my 30 times, my 30x lens, I get 30/60. And with my 40, I can get 40/80. And with my 50, I can get 50/100. So I effectively doubled the lens count with that one extra Barlow lens. And I have my pretty much 30 to 100 covered. And I did some amazing viewing with just that. I never even really reached for the 150 or 200x. And the things that I could see, these are all easy ones. These are the low hanging fruit. Jupiter, Saturn, Mercury. I would add Mars to that list. Venus. But I'll tell you that when we were talking about binoculars earlier, the other day we were walking to a performance at Maryland Hall, and somebody had some really nice binoculars that probably they had a pretty big aperture for binoculars, probably didn't magnify more than 10, maybe 12 times. It had a really good mount, and he was looking at Venus, and he was offering people views. And I knew that, you could, at that particular moment, you could see Venus's phase was very distinct. And with his binoculars, it was beautiful. I could have done the same with mine. I haven't used it in a long while, but I used to love looking at the moon when it was a really, really, really thin waxing or waning crescent, because you would get these long shadows that I don't know why I overlooked them with the naked eye. I'm sure binoculars would have helped too, but even just at 30, sometimes I'd drop in, I'd go up to maybe 50, which was overkill. But because then you can almost see, it's almost like watching, the heat waves coming off the pavement. You can see the atmospheric effect, but even that was kind of a rush to see that. I know I'm running way over time, so I'll wrap up. And then Pleiades, couldn't say more about that. Orion, and actually the constellation too, lots of beautiful things. Pleiades is just outside of Orion. And then you also have you mentioned Flame and Horsehead. I'd love to talk more about the techniques that you can use to bring out the colors, like averting your eyes and throwing the telescope just a little bit out of focus so that the pinpoint stars look like little balloons. And then they actually show their color much better. And then you bring it back into focus, and it's almost like your eyes remember the color that they saw, and you kind of attune your eyes to that. But yeah, I'll stop there. I guess the last thing I'll say too is I hope to see Uranus, because it's actually in the Pleiades right now. And it's about a magnitude 10, which is about the limit of what I have seen with that. Orion is like probably around that, but I'm sorry, not Orion, Horsehead. Orion's more like a 4. Just to put it in perspective, your Polaris is like a 1.5 or 2. A moon would be, so the magnitude limit that I've reached is probably about 10 or 12. Yeah, that's about it. Does anybody have any questions?
We have time for one or two questions.
Yeah.
General question, it seems to me that, it's about how much light you can get to what you see. This is an instantaneous, you've got a big aperture, so you get a lot of light. These things just get bits of light, or stack them onto each other until they have enough light to make an image achieve it instantaneously. That how sort of what's going on here?
Pretty much. And I guess One thing that intrigues me too is I thought about it when people were talking about, optimizing their using filters. For example, I noticed you have a filter wheel on yours, which I've seen on, I would love to have something like that to kind of tease out the colors of these things. But I'm sorry, what was your question? I just want to make sure I answer.
Get a big lens and do it all at once.
Yeah.
Get little bits and stack them together.
Bring in as much as you can and then tease out the detail by focusing on specific wavelengths. Yes, I would agree with that.
Okay, I think we're going to have to move on. Thank you, Matthew. Thank you. So I just have a summary slide here that shows the prices of everything you've heard about tonight. By the way, this will be recorded online, so you'll be able to see it. If anybody wants a hard copy of it, just shoot me an email so you can see the price ranges. So what we did was we saw from low end of Sextants up to, for example, Matthews around $1,450. So that's sort of estimated range. What you're free to do for the next 5 or 10 minutes is if all the folks who have their instruments could go behind them and you folks can go up, ask any question. We do have to be wrapping up about quarter of, but at least we got a few minutes here if you want to go up and ask some more questions. All right, thank you, everybody.